to the Yes to Life show on UK Health Radio, the show that explores the developing discipline of integrative oncology, in which all the resources of mainstream cancer care are combined with the burgeoning mass of techniques coming from the world of lifestyle and complementary medicine to improve the experience and the outcome of treatment. This week's show is part 5 of a 6-part exploration of the novel findings of Mark Lintern, who spent more than 8 years looking into the mechanisms and origin of cancer. All the previous episodes in this series are available on Listen On Demand. I'm speaking to Mark over the internet. Hi Mark, a big welcome back for the next instalment of Cancer Through Another Lens, our multi-episode deep dive into scientific findings related to the mechanisms and origin of cancer.
Thank you for having me. Nice to see you, Robin.
So this is part 5, and any listeners who've not managed to hear parts 1 to 4 are strongly advised to do so, as the material we'll be covering today is sort of built on the episodes so far, which have covered your research findings in quite a bit of detail. We've heard how you got started on this epic journey of more than 8 years, how you established the parameters for your research in this massive field, about your evaluation of the science so far, and about your search for some consistent factor or factors that would make sense of the highly predictable nature of cancer that up until now is being ascribed to totally random occurrences. You told us how your research became focused on one particular unexplained feature of cancer, the Warburg effect, and how you stumbled across a known reason for this behaviour that hadn't been previously thought of as associated with cancer. This led to your investigation of the work of Dr. Navio, who characterised the cell danger response, a natural defence mechanism used by cells under threat of infection, but one that, if unsuccessful, looks an awful lot like the beginnings of cancer. At this point, your attention was then focused on microorganisms as the driver of cancer, as this could provide you with a coherent explanation for both the mechanism and the origin of cancer in the form of the cell suppression model. In the last episode, we began to make sense of the random nature of carcinogens, and you identified the 4 common outcomes of damage to the body by carcinogens, and how these provide the ideal ground for local intracellular invasion by opportunistic microorganisms. We heard how you surveyed the range of microorganisms out there and homed in on fungi as the most likely villains of the piece. And we ended up last week with some first considerations of the implications of your findings for those with cancer right now. So that's where I'd like you to pick up now. Perhaps you could start by reiterating the very important message you gave about the theoretical nature of your findings, about jumping to simplistic conclusions, and about the dangers of self-medication.
Yes, thank you, Robin. Firstly, I'd like to say that I'm not a clinician, so I'm not qualified to be giving any medical advice. So anything we're discussing here today is not medical advice. It's just for information purposes only. And anyone listening should seek advice from a medical professional. One of the take-home messages probably people will take from what we're discussing today and my book is that fungal pathogens are intrinsically involved and may conclude that the solution, therefore, is to simply apply antifungal drugs. Now, I just want to be cautious with that because antifungal drugs are extremely toxic. And again, a medical professional should be consulted whenever attempting to use these particular drugs. There are many contraindications with other medications as well, so it's a very nuanced area and can be potentially dangerous if all options and all contraindications are not considered, and especially the health status of the patient at the time, which is obviously going to be variable from one person to the next. And in particular, certain drugs will affect people in various ways depending upon their physiology.
Okay, well, that all makes good sense. And, the basic story is don't jump to any simplistic conclusions, and can give some expert advice if you want to follow up on what's been researched here. So we started talking last week about therapeutic approaches generally. Firstly, I know you've given some thought as to the areas in which helpful approaches might be found. Can you tell us a little bit about this and about the science you found to underpin these ideas?
Yeah, I mean, there's a lot of information already out there. A lot of people, such as, say, Jane McClelland and Dr. Nasha Winters, have been looking in depth at metabolic approaches in particular to cancer. And these kind of go along the lines of starving the cancer cell of its energy supply, or the fuel that appears to drive it. What we also have is fixing the terrain of the tissue that allowed what I would say would be the infection to take hold, and rebalancing the microbiome, which appears to have become dysbiotic in most cases, which obviously has allowed certain pathogens, fungal pathogens in particular, to take hold. So at the beginning, it would be to target the terrain with good nutrition, reducing toxic exposure, and generally reducing inflammation, which is essentially the situation that caused the problem in the first place, reducing cell damage and supporting the immune system. Fixing the corrosive environment that occurred. But there's a lot of speculation around, I found, the fuels that cancer uses in particular. There appears to be confusion over which fuels are driving the disease. Now, from a metabolic point of view, and Professor Seafried would argue, along with Otto Warburg, that cancer primarily utilizes glucose because of glycolysis being the primary energy system that most cancers use. And this is not the case in all cancers. Some, I think it's particularly prostate cancer, uses fat as fuel. But also glutamine appears to be an interesting fuel. And all these fuels appear to be used at different stages and different levels at different times. So from this perspective, it is quite confusing. But with a metabolic approach, there has been success with brain cancers particularly, and this involves specifically restricting glucose. So along the lines of utilizing a ketogenic diet, which is a diet similar to an Atkins diet in a sense that we're restricting glucose to try and starve the cell from actually utilizing it. Because what we find is as well that with the use of glycolysis, cancer cells require a much higher amount of glucose than healthy cells because they're reliant upon glycolysis. And glycolysis utilizes approximately 18 times the glucose than a healthy or regular cell would use. So it seems an interesting and potentially beneficial strategy to essentially fast or starve as best one can using diet techniques or even glycolytic drugs that can block any particular energy pathways in order to restrict the amount of glucose that is available. Because healthy cells can utilize other fuels. It appears they can use other fuels to a greater degree and adapt better than cancer cells can. So if you're restricting the glucose of cancer cells, you're more likely to make them susceptible to possibly other treatments, other chemotherapy treatments, if you want to be using conventional treatments as well. So there's a lot, this is a very nuanced area. There's a lot of things to consider. But from my perspective, the reason why a lot of metabolic therapies would work is because a lot of the energy pathways that you will be targeting with the cancer cell are also similar energy pathways contained within fungal pathogens. So if you're restricting glucose, you're restricting the primary fuel of the fungal pathogen. Many fungal pathogens' cell wall are made of polysaccharides, so glucose essentially, or carbohydrates. So roughly around 90% of the cell wall of the fungi can be made from carbohydrates. So it's an essential fuel for the pathogen to survive, which is why it seems to have such a significant effect when we target this particular energy system and this particular fuel. Now, the interesting thing I found when I was looking at all these fuels and the confusion surrounding why some cancers appear to utilize fat or utilize glutamine is that when you look at the pathogen, it can actually utilize most of these fuels, because the contention has always been, well, if you, in some circumstances, if you restrict glucose, like in the case of Jane McClelland, I think, she restricted glucose via several routes, but it didn't actually prevent her cancer or kill her cancer. She needed to utilize other drugs as well, such as lovastatin, which restricts fat. So in some situations, restricting glucose doesn't appear to work, and there are many reasons for that we can go in a little bit later. But one of the main reasons I would argue is the research I performed showed that fungal pathogens, intracellular fungal pathogens, can adapt very quickly and easily to nutrient deficiencies or scarcity. It's how they survive immune cells once they've been absorbed by the immune cell. The immune cell will tend to generate a vacuole whereby they restrict all the nutrients that are available. So fungi have learned to adapt incredibly well to difficult situations where nutrients are scarce. So if you are restricting glucose, for instance, the cell itself will need to absorb other fuels, because what we've got here is a situation where the cell is operating on autopilot because the fungal pathogen is in control, and the fungal pathogen is sequestering nutrients from the cell. So the cell itself will always attempt to create balance or homeostasis. So if there's nutrients that are being depleted, it's going to increase receptors on its cell surface for glutamine or glucose in order to rebalance off essential nutrients within the cell that have been diminished by the pathogen. And what the pathogen can do, say for instance in situations where glucose is restricted and glutamine is being absorbed by the cell to compensate, the fungal pathogen can convert glutamine into glucose. And the same is said for fat using various pathways. So the glyoxylate pathway is present in certain fungal pathogens, and that is a direct conversion from fat to glucose.
Oh.
So these pathogens are extremely versatile, and when you look at how the pathogen uses these different fuels, one can begin to see and explain why there's so much confusion over the varying different fuel types that appear to be used at any different time in a tumour mass, because the pathogen can adapt to that. And it's not necessarily the cell that's adapting to utilise those fuels. It's the pathogen that's taking advantage of the cell absorbing whichever fuel it is absorbing to replenish lost nutrients within the cell.
Interesting. It also explains really why cancer is such a wily foe, why all these different attempts to cut off its fuel supply, it moves so quickly. It seems to evade so many of our efforts to kill it.
Yeah, not only that, but the body adapts as well. So in a process called gluconeogenesis, the liver can actually repurpose glutamine into glucose. So if you're restricting the body through a glucose mechanism such as fasting or whatever, the body itself will always try to balance the glucose available in the bloodstream. So this is one of the many reasons why just restricting glucose in the diet is not necessarily going to work for everybody. So you may think you're restricting glucose, but the body is still working hard, the liver is still working hard to generate a situation of homeostasis within the body, or balance. so the fungal pathogen can also access this fuel. But this is where you can use particular drugs. And again, I'm not a clinician, so I don't know the specifics, the ins and outs of applying these drugs to this particular situation, but you can use drugs to block certain pathways, the gluconeogenesis pathway. I think metformin is one, and block glutamine. So Jane McClelland does a great job in her book of identifying many of these pathways and many of the off-patent drugs as well that are able to block specific pathways and aspects of the cell in order to starve the many different fuels and amino acids that cancer cells appear to use.
UK Health Radio, the station that makes you feel good. UK Health Radio, the station that makes you feel good.
Okay, so the take-home message there is that a lot of these techniques which have been developed specifically for starving cancer cells of through various energy pathways are, well, obviously they're useful because they're working for people, they're helping people, but they might be helping them for more than one reason. It's not only is it depleting the cancer cell itself, but if your view is correct, it's depleting the thing that's driving the cancer cell if it's done well.
Yes, so it seems that a lot of the off-patent drugs that are also used, so for instance, lovastatin or a number of the statins, they're assumed to be targeting fat, and they will be doing that. They'll be preventing the ability of fat to be utilized by the cell. But what we also see when we consider this cell suppression and fungal perspective is that most of the drugs, such as metformin, lovastatin, they're also antifungal. So they affect the fungal pathogen directly. So one has to ask, well, are they effective in the sense that they're also working almost on two levels, by directly targeting the fungal pathogen and by targeting the fuel that the fungal pathogen needs in order to convert into glucose?
Yeah, no, I see that. Okay, so that, if you like, is looking at things from this metabolic point of view, from the energy point of view. Now, an awful lot of treatments are simply anti-cancer, which means that they aim to target cancer cells and kill them. Now, that they could be orthodox treatments, they could be natural treatments as well. That's another way of thinking about cancer, if you like, and another way of blocking its momentum by simply reducing the number of cancer cells that are active. So obviously that's being looked at from the perspective that the culprit here is the cell. It's the cell that's gone wrong, and therefore you try and kill the cell. Now, there you are, you're looking at it through this lens of a cell that's been controlled by a fungus. How does these kind of treatments, how do they look through that lens?
What conventional treatments? As in toxic chemotherapies, for instance?
Yeah, well, those, for instance, or indeed any natural anti-cancer approaches that anybody might take, ones that are directed solely towards killing cancer cells.
Yeah, okay. We'll take the natural side of things first. There's always been this question of, we see anecdotal evidence and other evidence, preclinical evidence, of natural substances, natural compounds from everyday foods, really, that appear to be effective at killing cancer cells selectively. So, healthy cells don't appear to be affected. And all the time we're looking at the pathways that seem to be changing in the cancer cells and attributing the benefit of these therapies or these natural compounds to the ability of them to change particular pathways that the cancer cell is using. But essentially a cancer cell is still the same as a healthy cell. It's still got all the same pathways. We're just assuming that it's developed a mind of its own and it's manipulating particular pathways on purpose. But looking at these natural substances and the fact that they change the pathways selectively in cancer cells, there is no explanation as to why these natural substances are able to selectively target the cancer cells.
Right. How do they tell the difference between a cancer cell and a healthy cell? Right.
Yeah. Why is it, for instance, that maybe cannabis is affecting a particular pathway in a cancer cell, but is not affecting the same pathway in a healthy cell? Well, I would argue, and in some of the evidence I've found, is that the fungal pathogen manipulates a particular pathway. And then what we see occurring when using, say, cannabis, that particular pathway will be diminished because it's been upregulated by the fungal pathogen. So could it be that cannabis, which is antifungal, is actually compromising the fungal pathogen's ability to continue to manipulate that pathway, which makes it more susceptible to being killed by the cell or by the immune system? Or could it be killing the fungal pathogen directly? And then we're seeing the change occur because the pathogen is now no longer in control. So I would argue that there's a potential explanation for why many natural substances are effective, and that's because they're antifungal naturally.
Right.
When it comes to chemotherapy and other drugs, what we see is they can be effective initially at reducing tumours, and there certainly is a place for conventional chemotherapy treatments. But as a precaution, I have to say that cytotoxic treatments like this, the evidence seems to be that if they don't knock out the cancer stem cells, then they risk stimulating them to become more aggressive. And our body is designed to essentially repel toxic substances. And I think that's why sometimes it's important to have this discussion about natural medicinal products, because most of the time they work synergistically with our cells. So if they are targeting the fungal pathogen and they're not damaging the cell is more likely to absorb them and they're more likely to utilize them. So it's very important to think about that side of things. But also the conventional side, which is to use toxicity to damage the cell. Cells are going to react in a way that tries to restrict that level of toxicity. And we know that stem cells in particular have efficient antitoxin pumps in them compared to regular cells. So they are quite resistant to chemotherapy treatments, for instance. Now, the other thing is, when, say, using chemotherapy, a toxic chemotherapy occurs, what we often see is a huge reduction of the tumour. So we're there thinking, oh, this is great, the chemotherapy, it's targeting the tumour, it's reduced it a great deal. So the oncologist accepts that they've had a victory. However, from what I've been researching, suggests that if this continues and the immune system isn't strong enough to continue to help defeat the tumour itself, the tumour remains after a certain period of chemotherapy treatment, it becomes more aggressive. Now, this is possibly because it's a survival response, essentially. We see this in other animals where amphibians, for instance, they lose a limb or they lose a tail and they're able to regrow that tail. Same with jellyfish and various other, even with plants, roots are grown in places where you cut the stem where there were no roots before. So you have this process of, it's a survival mechanism. And we have a similar process where if you have a certain level of damage to cells, cells are able to convert themselves, or regular cells that have differentiated into a specific group, such as skin cells or eye cells, whatever. They can be reinstigated into a stem cell-like phenotype, which is a transition back from a regular cell into a stem cell-like state that allows those stem cells to regenerate tissue. Because stem cells are superhero cells in the sense that they can create other progeny or create other cells of different kinds, where regular cells can't do that. So when you damage cells to a large degree within a tumour mass, what you're doing is you're causing extreme damage to mitochondria in those cells. And those mitochondria can instigate upon that damage, retrograde signaling, which signals the cell to revert through an epithelial to mesenchymal transition into a cancer stem cell. So if you're not killing the whole tumour, but you're creating this mass damage, what you've got is a bunch of cells that are working together and are kind of realising that there's immense damage occurring. And in order to survive that immediate environment, those cancer cells convert into cancer stem cells. And then because such a mass of cells have been killed within this tumour mass, and these cancer stem cells are all related to these other regular cells, it's almost like they're a separate organism, they will duplicate themselves in order to replenish the cells that are lost in such a large number. And then what you have is ongoing chemotherapy cannot kill those stem cells, and you've got an increased level of cancer stem cell growth, stimulating regular growth. Furthermore, chemotherapy will weaken the immune system and weaken mitochondria, which means chemotherapy is producing fewer free radicals as time progresses. And all the while, if we bring in the fungal pathogen into this situation, the fungal pathogen is killed by the free radicals initially that are produced by chemotherapy. But over time, if they exist within cancer stem cells and are protected within that niche, the fungal pathogen will increase its superoxide dismutase, its antioxidant defense against the free radical attack that chemotherapy generates. And as that free radical attack is diminished over time, because mitochondria are weakened and diminished through the damage of chemotherapy, the fungal pathogen becomes stronger. Furthermore, certain chemotherapies also damage the microbiome, the beneficial bacteria that can also keep fungal pathogens at bay. So again, the fungal pathogen in most situations appears to benefit from all these different fuels and certainly several toxic treatments that we use.
Right. So whereas you certainly described the idea that chemotherapy is sort of promotes cancer in the long range as being controversial, in mainstream circles. There's actually now quite a lot of research, and quite a lot of people would support the idea that actually that's true, that it actually does drive cancer after a certain point if just used indefinitely.
Sure, and I'd just like to say as well that, there is potentially benefit to chemotherapy. Yeah. Like if you, in instances where you may need to reduce the tumour before you can use surgery on that tumour, then chemotherapy can do that initially. The problem is it's so destructive to the rest of the body and the immune system that I believe long term it's a negative influence. So it's very nuanced. It has to be taken into account. I'm not saying that chemotherapy doesn't work. It will work in some cases and has worked for a number of people. But in my opinion, it all depends whether or not it's able to knock out the cancer stem cells, and particular chemotherapies aren't targeting cancer stem cells, and cancer stem cells are largely resistant to a number of chemotherapies. So it's important and beneficial to be able to possibly be used and aid with surgery, right, for sure.
So a tool to have in the toolbox for emergencies, a useful tool to put alongside many others.
Yeah.
Okay, well, that's interesting.
UK Health Radio, the station that makes you feel good. UK Health Radio, the station that makes you feel good.
You referred a few times to dysbiotic microbiome and how this plays into the whole thing, and how some of your approaches to treatment would be to try and correct that. So I'd like to just explore that a little bit now, and just maybe you can describe the role of the microbiome generally in keeping us healthy and cancer-free, and what goes wrong under what circumstances that actually aids the spread of cancer, and from your view, the spread of fungal pathogens.
Okay, so the microbiome, incredibly, I was shocked when I read this, that the beneficial bacteria, particularly in the gut, actually form around up to 80% of our immune system defense. So these little bacterial critters are defending us from toxins produced by other pathogens, toxins that are found within the food. They're keeping the number of pathogens to a level that doesn't cause damage to our body. They are also producing essential nutrients, tryptophan, for instance, but essential nutrients that our body requires, vitamins as well. So they are a critical aspect of health. I only touch on them briefly within my book, but it's very much worth learning as much as you can about the microbiome, because a dysbiotic microbiome, particularly in the gut, can also have major issues elsewhere in the body. I think there were a couple of studies that I have in my book that highlight when you have an overgrowth of candida or various other pathogens within the gut, they can cause inflammation to occur in the lungs and disease to occur in the lungs just through that connection. And there's many other connections with our spiritual side, our brain, through the vagus nerve. We have a connection from the gut to the brain. It's incredibly complex, but essential to keep the microbiome healthy in order to keep us healthy, because we are an ecosystem. We're not just a bunch of cells operating in a mechanistic way. We are essentially a huge ecosystem with trillions upon trillions of microorganisms that exist within us, for us, and with us to essentially improve our health. We cannot live without these microorganisms. So in terms of what happens to probably facilitate cancer and fungal dominance, is that we are exposed to a lot of toxins in our environment these days, a lot more than we used to be. Furthermore, we're also exposed to a lot more antibiotics, not only through the overuse of prescription antibiotics for patients, but within the food we consume and with our environment. There's many studies that have been done to show that antibiotics are frequent within the river systems that we have around the world, because they're used within farming, essentially. So they're present in the meat that we eat if we're not eating organic and locally sourced or well-sourced food. So we're exposed to these antibiotics to a much greater degree than we actually think. And these, of course, will cause an imbalance within the body, within the microbiome itself. Not just that, but the poor nutrition, our diet, our level of the different levels of microorganisms that exist within our body are dependent upon the food we consume. So the more natural food we consume, the more beneficial microbiome we seem to have. If you start introducing the Western diet, high in refined sugars and processed foods, we have a switch that occurs within the microbiome that appears to favour more pathogens. So it's incredibly nuanced. But I would suggest that because of the increase in sugar and glucose and refined sugar that we consume from our poor diet in the West, and the antibiotic exposure we have, as well as the inflammation that occurs through the foods, inflammatory foods that we use, the fungal pathogen is able to gain dominance in particular situations. And we have a separate microbiome, it appears, for each organ within the body and each area within the body. So it's important to make sure it's not just the gut that we're looking at, it's the microbiome everywhere in the body, and that we should be reducing inflammation as much as possible. And these fungal pathogens, being very hardy as they are, can take advantage of any situation where the microbiome is diminished to their benefit.
So, interestingly, the message here that metabolic science has brought to us, that basically you should eat the best food you can, reduce the toxins in your body, all this kind of thing, applies exactly the same in your model. You may be taking fungal pathogens into account to a far greater degree than they might have been accounted for otherwise, but nonetheless, the message about what you do in order to avoid health problems and to put yourself in the best position when you're facing something like cancer are exactly the same.
Yeah, this is the same message that Dr. Naisha Winters was talking about in her book regarding looking after the terrain. So it's all about the terrain, really. If you're not eating organic food, and there's this debate between organic and conventional food grown with pesticides, organic food is shown to be much more nutritious. So if you're not providing your body with the nutrition it requires, and the food you're consuming contains pesticides that are inflammatory, then you're damaging your terrain without realizing it. You're thinking you're eating a healthy diet, but you're damaging your terrain, which is causing inflammation and other consistent damage. That you're also diminishing the protective ability of your microbiome to look after your body, and you're stimulating fungal pathogen growth through the over consumption of glucose and sugar. So all this, you're damaging the terrain, you're causing the environment in which fungal pathogens opportunistic fungal pathogens, if they are present within particular tissue, can take advantage of that and do take advantage of that. So yes, it's about, it's common sense, really. To me, it's common sense, just being healthy. We seem to have this idea in life that we can eat whatever we want and we'll take a pill and it will solve every ill. But that's not really the case. You have to look after your body simply by using the same natural ingredients that we've been consuming since time immemorial, really. And it's only recently that we've introduced so many toxins and so many processed foods that we're damaging the terrain and allowing these fungal pathogens to take hold.
So the healthy lifestyle choices message is underlined by your scientific findings.
Well, yes, there's studies into blue zones. The National Geographic did a 2-year study into blue zones, and that looked at why those particular areas of the world were healthiest. And you only need to look at them to realise that it's all about natural foods, exercise, minimal meat, and minimal sugar, and it's just organic. And it's just, if you want to understand what a healthy diet is, study these zones that have been studied over the years.
Okay, great. So you already mentioned, like when you were talking about repurposed drugs, you mentioned the fact that, okay, they're using repurposed drugs because for the reasons that they found that they block particular pathways. Well, actually, the reasons they're using them are actually because they find they work. That's been noticed first, that they actually do work. And then they've thought about, well, why do they work? And they've come to the conclusion that it's because they starve cancer of particular fuels. But you made the point that many of these drugs happen to be antifungals, and so maybe the way they're working is not exactly how they thought. Now, I know you've taken quite a broad look across cancer treatments at various approaches which are successful, at least to some degree, and you've kind of reinterpreted them by looking through the lens of cell suppression. Do you want to just tell us about a few of those?
Yeah, so for instance, the Care Oncology Clinic uses 4 particular drugs: metformin, statin, doxycycline, and mebendazole, which I think is an antiparasitic drug. These target various aspects of cell metabolism, but when you look through them from the perspective of fungi, they all, within their own right, are antifungal drugs. So the potential here is that they're also targeting the fungal pathogen as well as particular pathways directly that the cancer cell is using. There's other treatments such as hyperbaric oxygen therapy. That is also antifungal.
That's used for things like leg ulcers and things, isn't it? Because it's so effective at cleaning up infection.
Absolutely. But there's other things such as intravenous vitamin C therapy. So, I mean, these are controversial in mainstream circles. And artemisinin as well, which is an anti-malarial drug that is in common use and deemed safe. Now, the other thing is that we're still trying to understand why these drugs appear to work, or why these interventions appear to work. and a lot of them work through the process of generating free radicals, as does chemotherapy. Chemotherapy damages the cell to generate free radicals. But artemisinin and intravenous vitamin C therapy, for instance, is able to actually create peroxides that specifically interact with the iron. And we see a lot of tumours have this problem where they're expressing iron because they can't contain them because they're damaged. So we have this iron, this freely available iron, and iron reacts very negatively with oxygen and peroxides to cause free radicals. So artemisinin and intravenous vitamin C appear to work in that way, where they are reacting with the freely available iron. Now that makes these therapies, or potentially makes these therapies, targeted therapies, because what you've got is this reaction with the iron in cancer cells only, because the iron within healthy cells is contained within ferritin and other proteins that contain them, so it's not freely available, so this reaction doesn't occur. And I would argue the reason why that works is because the generation of the free radicals are able to kill the fungal pathogen, because this is what the immune system utilizes to kill fungal pathogens, among many other metabolites that they produce. Essentially, cells and the immune system can kill fungi using these free radicals. So it's this generation of free radicals through other means other than conventional medicine that can actually kill the fungal pathogen and benefit cancer patients. And I think the problem, again, with chemotherapy is that it's toxic throughout all of the body. It's not selective. So it will also generate free radicals within healthy cells, as opposed to intravenous vitamin C therapy would. Tamoxifen is utilized for breast cancer, essentially to disrupt the hormones that appear to also be stimulating cancer. But tamoxifen itself, as well, in studies show that it's an effective antifungal drug. So again, what we see is pretty much most of the drugs that are utilized in an alternative fashion or off patent or currently being used in mainstream also have this antifungal quality that I think we need to look at just to double check to see if I'm right about this view, because we're always looking at cells and how the cell is affected directly by the drug and interpreting it through the change that we see. However, there is this other issue, this other angle we need to be looking at to just double check to see if we are actually killing a fungal pathogen, and that could be the underlying mechanism that's causing the change with these particular drugs. One of the effective mainstream drugs that have been created, which is Gleevec, seems to actually operate slightly differently than its purpose is suggested. It seems to operate by reducing glucose as well within the body. So it's almost, rather than working on a DNA restriction, a DNA gene restricted base, it's actually restricting glucose within the cell through a different mechanism. And of course, restricting glucose in that way is going to also affect the pathogen. So it's not directly antifungal per se, but through an indirect mechanism of glucose restriction, Gleevec seems to work through that mechanism.
Interesting. It's just so fascinating to look at all these existing treatments and just, recheck, if you like, what is actually going on there, and maybe it's different to what's been thought so far. All right, well, look, you've done this massive amount of research, and I just kind of wonder, how do you know when the time had come to step out with your findings? I imagine that, the field of cancer research is so vast, there must always be more questions to be answered. How did you know the moment had come to step out into the world with it?
I think it was when I was talking to myself and then answering my own questions. Yeah, I was going a little bit stir crazy because I've spent so long on my own. But the real point was I knew when I was researching for so long that when I came across other aspects of the disease, aside from the 10 hallmarks that I was trying to explain, such as iron overload, why does that increase the risk of cancer? I had to explain these other aspects. And it got to the point where I'd researched so much that I couldn't find anything else at that particular time to explain. So in my book, I point out that I don't just explain the 10 hallmarks of cancer, but I explain at least 20 other conditions, and I've listed those 20 other conditions associated with the disease, such as iron overload and maybe arginine auxotrophy, as 2 examples that scientists are struggling to make sense of. So I've also made sense of those. And it was when I reached a certain point of, okay, I've explained 20 of these extra other points and others beside that I don't actually list in this table that I've created. I thought, I've got to stop now. It's coming on to 7 years. I think now I've had enough. Plus, my relationships were suffering from it as well because I was spending so much time on the project. So it just literally got to that point. It's 7 years. Couldn't really find other major things to explain on the disease. So now it's time to take it forward. There are other aspects of the disease that do need explaining as well. Don't get me wrong. I don't, explain everything. And there's more research that I would like to do. But I did establish a certain level of, I did perform a certain level of detail that now needs to be put out there. So I thought, let's stop. Let's get some semblance of my life back and get this out there and see where we go from here.
Brilliant. So that's where our paths crossed, and that's where I'm going to end this week's chat. And I'd like to start from there next week, which will be the last episode, and talk about what happened from there on when your scientific findings were put under the dazzling lights of scientific scrutiny. So as it's going to be an exciting last episode, what's happened since. So thanks very much again for an interesting chat, Mark, and look forward to the last episode.
Thank you, Robin. Thank you for having me.
See you. Bye.
Thanks, Robin. Yeah, bye.
Okay, just one more episode to go, and it'll be a hugely interesting one. Meanwhile, if you have some catching up to do on earlier episodes, they're all available on Listen On Demand. Just go to yestolife.org.uk, scroll down the homepage and click the link to the radio show page. If any listeners are in an urgent position in regard to cancer and are thinking about the personal implications of Mark's new ideas, I'd like to let you know what resources there are. There's a pre-publication release of all the key chapters of Mark's forthcoming book, available under the title Cancer Through Another Lens from the Yes to Life shop, which you can access by going to the Yes to Life website, that's yestolife.org.uk, and clicking the link to the online store right at the very top of any page of the site. Professionals listening may also be interested in this, as they may want greater detail and access to scientific references ahead of the book publication later this spring. And as a further resource for professionals, we have now released a 3-part CPD video course on our Horizons platform, which comes as a bundle with a raft of other useful materials. You can find out more about the course by going to the Yes to Life website. Again, that's yestolife.org.uk. Click Education and choose Professional. Yes to Life advises anyone against self-medication, as cancer is such a complex and individual disease. So we've prepared a list of practitioners who are up to speed with Mark's new ideas and can help anyone with the implications for therapeutic support. For more information, contact the Yes to Life helpline by calling the number that's at the top of every page of our website, which is 0870 163 2990, or by filling out the form on the helpline page, which you'll find under the I'm New Here menu on the website. Thanks for listening today. I look forward to bringing you part 6 of Through Another Lens in next week's Yes to Life show here on UK Health Radio. Goodbye.